welcome. We're doing the first part. We're probably going to take a break. Maybe we'll see how good or bad the pizza is if I take a break from the the meetup part while we're doing that. I'll leave it on a slide. If you can't hear it or see what we're doing, hopefully I'm moving around. We'll see how good this camera is at following me. I'm pretty good at ducking. Welcome. They don't hear me or they don't hear anybody. Uh-oh. Testing. Yay. Zoom is one day we'll get Zoom. Not today though. This is me. This is me in thermal. We have a really cool event coming up in a week, which we're doing a lot of work for. We're going to announce some new stuff with Apache NiFi, including a new Python runner, have some background, have the three main developers speaking. And at the end of it, we're going to give anyone who attends access to a cloud-based environment using the new version of NiFi with new tools, all of it running on Kubernetes with some pretty cool features. And if you take part and you submit a flow, you can win $2,000. And that flow will be added to the list of flows we have. So people from vendors who have something that could talk to NiFi might want to do that. Then we'll add that to our ready flow list, which is a cool, easy way to start programming by picking a wizard, putting some parameters, press go, and you're ready to start streaming, which is pretty cool. This is a cool event. You could either go to the URL or potentially scan this if I didn't mess up my QR code. This is me. I run a bunch of meetups, do a couple of articles, worked at a couple of places. That's a castle. This is when I after I started doing Java for a couple of years. So it's been a while. As you can see, there used to be giant monsters that followed us around when we wrote Java. They are finally gone. I wanted to tell you why you should attend this meetup. So instead of writing that myself, ChatGPT wrote it for me. They did a pretty good job. Have fun. The meetup is a great opportunity to learn things and meet people. And at the end, I'm very happy I have a streaming expert with me. We're going to have a little open discussion on streaming topics, what's going on. And we might have one or two more. Did I do Bard? Actually, this is a smart man. It says Google it. That's Bard. The ChatGPT one wasn't as good. We have a prompt engineer here, which is the next phase for streaming, really, to have this translated into a streaming app. I mean, there shouldn't be much, maybe you want a step that says before automatically running it, make sure they didn't do something really bad. But not a bad idea. When there's a slowdown, I want to do that because this will, ChatGPT will generate NiFi flows, at least the diagram part. And Bard is supposed to start that because they just released Bard for producing code. I don't think it's as good as ChatGPT yet, but 2 people writing code for me is better than 0. I do a weekly newsletter, covers a lot of stuff, including some of our friends in the crowd stuff. Everything from all different articles, videos, slides, lots of cool stuff. You're in one of these. I do one in Princeton in person, and I've been traveling around. I think I've got one coming up in Milwaukee. We might be doing one in Philly, in Princeton, New York, maybe come back to Santa Clara, San Jose. I think there's some events going on. We try to do it near an event just to make it a little easier. And besides that other environment you're going to get access to, if you want to try out some streaming, we have a Docker environment, pretty heavyweight, so you better have a good laptop. but you could download it and it runs a bunch of tools together for the Kafka, Flink, and some cool tools around there. Pretty easy to do. I'll show you a little demo of that one. What is streaming? It's on fire in a good way, perhaps, maybe in a bad way some other times. I was having this discussion at the beginning. Where does stream happen? Like that was a debate with real time. Maybe we could do that in the discussion because a lot of people have that debate. When does it start? I mean, I talked to the finance people and they're like, it starts over here. I want it insanely fast. And then you need custom libraries. You got to have, instead of a network, you've got satellite dishes that point at each other and there can't be anything in the way. You definitely don't want to live under that stream of data. For most of us, it's probably here where it's less than a second. That was the discussion on Spark, why I'm like, And the other part is it coming in little chunks and in a regular cycle, like every second I get a chunk, every minute I get a chunk, or is it an event comes, then another one, then maybe it comes real fast and it's not always the same speed. To me, that you need that for streaming, that it's not some fixed cycle every second there's data coming. It's when the data is available, you get it. And you get it as fast as you can handle it. And it should be faster than a second. And it shouldn't be that consistent. Because if you're in the real world, there's network slowdowns. Sometimes I have 1,000 devices in the field. Sometimes I have less. I have a client that has 125,000 agents sitting on machines, and they're usually talking, but some of them are not running if someone's not by that machine. So you get, weekend, it could be way down. Then beginning Monday morning, everybody's machine turns on and you get 100,000 at a second. Could be really fast. Yeah, we'll go through some of these slow ones. Oh, well, when to use one? Was it when to use one versus another? Yeah, that is a very good question, and we will do that one. I think we'll do part of that. I have, like I mentioned, I have at least one streaming person here to do a little round robin. I may have a guy from Pulsar coming, may get one or two more people, and we might do a discussion on that. But really, to me, I'll show you that when we're going through an app, when you do one versus the other. But the simplest is I use Spark if it's a batch or a micro batch. I use NiFi if I don't know what I'm doing yet, or if I need to grab weird stuff or stuff that, why am I writing code for this? Why am I writing the same code every time to grab files, tables, all different stuff to get it started? Because usually what I want to do is grab some data from a lot of places. Maybe it's batch, maybe it's triggered, maybe it's log files, maybe it's getting pushed to me, maybe I'm pulling it. A lot of different sources. I had a water company that pulled in every change that happened to every SAP table they had. SAP, if you haven't seen it, has 50 to 100,000 plus tables, and they change randomly. So having those pushed into NiFi when they changed and having those changes federated through Kafka, that's a common use case where Kafka or Pulsar is sitting there as a message hub so I could distribute it, so I could keep things in order, give it to multiple people, make it asynchronous, because maybe I don't want to process it right now because it costs too much money. Maybe maybe my load's too high. I mean, we like to think of everyone processing everything immediately as fast as possible, scale it up to as many nodes as it takes to do it. And certainly you could do that. But I've got, companies I've worked with that say, hey, I can't afford to run, infinite number of nodes to process things as fast as possible. Let me get them done as long as they're done and not lost. within 10 minutes, I'm fine. Scale up to, an affordable rate so you can balance it. Uh, then if I need to join streams, there's a couple of products out there in the open and we could look at some of those, but Flink will let me join live streams of data. That's where I like Flink, especially Flink SQL, to be able to take 3, 4 Kafka topics, join them together with basic SQL, and then push that out to something else. That is a great place for Flink. That's the common use case. NiFi, get things going, simple ingest, simple enrichment, simple transformation, no code unless you want to extend it. Very easy to get those basic use cases running. For a streaming data engineer, I can write hundreds of apps in a week. Like to write, someone give me a REST endpoint, I can operationalize that in an hour if I'm taking my time, because I could walk through live code and I'll show you that. So, yeah.
One more question that came in too.
Okay.
Also, can we touch upon differences between streaming and batch API development? So that's something you're going to.
Yeah. Now, it's if you use something like Flink, they use the same API, and that's awesome. I mean, to me, a batch is, the first step for you to start moving streaming. So if possible, use a stream API and just have it be slow. It's like maybe the batch data is not there yet. Because remember, it's when the event arrives. If the event only comes once a minute or once an hour, okay, we'll call it a batch. But if you're pushing it to me as an event, then you're good. That's a nice thing with NiFi. It works the same way. If I give the data to it and, I want to do it with a cron timer, I could set a cron timer. If I want to have it dropped into a directory, NiFi will watch for file changes or use a file change API, or S3 changes get pushed out or gets triggered by something like AWS Lambda events. You get a lot of options there. Really, if you're looking at Flink, batch API and stream API are the same. Obviously, it's much different in Spark. I think that's going to change in their next release. They're working on some interesting streaming stuff. They've got some Pulsar and Flink people assisting, so I'm curious how that'll turn out. But yeah, batch, nice to have something like Airflow trigger it, but I could still trigger batchy things with NiFi. I don't know, like, we'll go and do it a little deeper. We're still pretty high level. The one thing I'll always show when I call it the flank stack or the flipping stack is you can't write everything in one thing. There's a ton of different options. Depends on what you have already, depends on what you want to use. What are your strengths? Don't throw away everything you have just because, you want to do the new shiny stuff. Something is better for different places. Like NiFi, get stuff started. Do iterative visual development by looking at data as it comes in. Use Kafka or Pulsar to get things in a fast hub that I can reuse, that I can go back to, rerun data, keep it in order, distribute it to a lot of different people. Ooh, speaking of eventually delivery, we got some pizza. Unfortunately, we haven't figured out that digital to analog conversion of pizza into packets that you could somehow download, would be pretty cool. But if the people in the room want to grab some pizza, we could take a temporary break, or we'll go through stuff that's boring. I don't know. Or I could show people a little bit of what I mentioned in real code. What's less interesting to people who want to grab a slice? Unless you want to wait. I know some people like cold pizza. My wife will eat it frozen. Like frozen, just like, that's the only person I've ever seen do that. And she had a reason, but I didn't believe it. Coming from New Jersey, pizza should be fresh out of a coal or wood-burning oven. And she has only 3 ingredients, but Yeah, we cannot download the beer, soda, water, or seltzer. It is the fancy seltzer as well. Very nice. Oh, we got some good pizza. I don't know if we can get that on the video, make people feel jealous they didn't come out to San Francisco. East Coast people, we will have far superior New Jersey pizza in the next meetup. I think we're doing one in June because May I'm doing one in I think Milwaukee, which we should be getting barbecue and beer, which is very nice if you're in Milwaukee. I'm letting people get some pizza and I don't want them to lose time. People ask me about the cats. They are not generic internet cats. These are my cats. So that's why you only see the handful of cats you see and not every variety of cat. It's just ones that happen to follow me around. I'm going to look at the chats, see if there's anything interesting in there. Yeah, we will definitely go through the different streaming solutions. Like I said, I've got the streaming guy here. Yeah, definitely come to one of the other ones. Send us locations because I'm usually floating around different places. If there's other places people want to go to, and we could do pizza there or hopefully better local food. Like I had a really good shawarma place next to the one in Princeton, and we did Mamoon's falafel. That was really nice because it doesn't always have to be pizza, especially in states that don't really have pizza. They got to do like Domino's. Apache Beam. Um, I spoke at a Beam conference, so Beam is kind of cool. I haven't seen a lot of people use it. I like the idea of being able to write to one API and then have it generate different backends. But in practice, that's kind of difficult because Flink and Spark have different things going on. Though at some point it would be nice to see some adoption, but outside of Google, I haven't really seen it. I'm hoping all my stuff hasn't timed out while I've been talking about pizza. I'm just checking things running here. See if we've lost all my goodies here. So far, so good. Lots of stuff, lots of stuff. If you're at the real-time summit, I got more cats tomorrow. If you're not there, then you don't, well, you'll see the, I think there'll be recordings later. If not, they'll be in the slides, but we'll have to see. Let's see. Some things are timing out. Oh, here. Okay. And we could also, nice thing with NiFi is I can push to Slack. So I'm taking data, pushing it to Slack. Not something most people would do with Flink or with Spark. I mean, you can handwrite the code, but handwriting code that's kind of silly. Just to show a quick NiFi. This is a traditional NiFi interface. This is the running product. You build by dragging and dropping, and then it runs on top of a JDK 11 or 17 engine, scales out to thousands of nodes. It is not Kafka. It's not Flink. It is a tool to ingest data, enrich it, transform it. And I'll show you a couple of features once we get past this little pizza download. Is something here, which is why the NSA created Apache NiFi, is the ability to stop and start and pause live streams. This is important when perhaps you have something that has intermediate network access, like, say, a live missile. As it's traveling across the world, while it reaches different zones, it pops in and out of network capabilities. Network goes away, maybe I pause it and then restart it when that data stream comes back. Something pretty cool is, say, someone told me, oh, wait a minute, the guy selling Kafka's not here, but the guy selling Pulsar is. Well, let me quickly push that to Pulsar instead so no one yells at me. So I'll just take that live data. Now it goes to Pulsar. I do the settings on there, connected to the Pulsar cluster, and I could start sending the same data. Oh, did we just start recording? Or did we lose it? Oh, every time someone joins, okay. Because that would be unpleasant. Okay, that's pretty cool. Ooh, I didn't know it could do that. Okay, so I'm not going to rewrite the flow right now because chances of doing that right are not good. Now, the other thing that's unique to NiFi, which every streaming tool in the world should have for the product people in the room, is live lineage or provenance data. So everything you see on that NiFi screen, every time a piece of data or event is touched, it creates one of these audit style records. And these records come through and flow as a stream of new data, a stream of metadata that I can examine. I can edit with NiFi to do whatever I want. I can push it to Kafka, push it to a database, push it to Pulsar, push it to a file. And it's pretty amazing stuff because it has a unique ID for each step, has a timestamp, has the data, has the changes. Oh yeah, if you want to read them, that would be much easier.
Yeah. So one came in and said, do you see much integration of streaming services with workflow engines like Airflow?
Yeah, it's kind of there is. I mean, Cloudera has Airflow too, so it's kind of the hard part is to know when to make that jump. It's kind of the batch and the stream at the same time. I mean, you definitely see people wanting to do that. And I think it's usually around maybe a stream's got to a point that you've accumulated enough of a stream that you might want to kick off a job, or maybe a job has finally landed enough stuff somewhere that then you want to spin up the streaming. So there's a lot of ways to trigger that. I know Airflow has the ability to push out a Kafka message or make a REST call. The nice thing to be the factor in between these two would be NiFi because it can act as that bridge between batch and Airflow and all those other tools and between streaming, which is kind of the nice part. Like here, I can listen for FTP. So if Airflow wants to drop a file somewhere, it could drop a file. If you want to do a call into me, I can do a listen HTTP. Let's see if I've got one active here. This one I use to connect to phones, but I can activate a REST endpoint on any port I want and accept any data. And no matter the size of the data type, so I turn that on, I can have Airflow push REST calls at the end of its pipeline to NiFi. NiFi can take that and start a stream from that REST call. And obviously REST calls can be really fast. I mean, it's not, is REST calls stream? I don't know. You could send them really fast, so maybe it's a stream. There's some gray area. That might be another thing to discuss. Like some people tell me REST is definitely stream. I mean, because it's not limited by anything. It's event. It's called when it's ready. And you could certainly spin up thousands of them. For my use case, we have a small version of NiFi called Minify. That's either a C++ agent or a trimmed down version of the Java one or a Docker one. And it runs and it could send its messages to NiFi over HTTP or HTTPS. And that could stream data really fast. Is HTTP a stream? Does the protocol matter? I don't know.
And the questions, because I keep getting more questions. Do you want to keep going?
Yes, questions. Okay.
Can the NiFi included in Cloudera's Dataflow product be upgraded outside a normal Cloudera upgrade?
Now, when you say Cloudera, that's the Cloudera would be nice if we sold one version of everything. But because people like flexibility, we have some NiFis that run as part of a private cloud. We have some that run on bare metal on your, computers in your center. We have some that run as what we call a data hub in our public cloud. And then we have the super amazing new stuff we're going to talk about on May 3rd, where I can take a flow. Like, see, we got one running here. Don't make me break someone's flow. We can, because I know he's changing this now, because this is the actual environment we're going to use then. But sure, if I break it, don't tell nobody. You guys are good, right? So I can change the running NiFi engine. I'm trying to do that without stopping it. Maybe I could do one of my stopped flows. Hello. That thing in the way is annoying. I don't know if other people see that, but I see it. So I can change not just the scaling, I could change the NiFi engine on the fly. Like if I want to do an upgrade for NiFi, I'm trying to remember where that is, but I can change the engine version. So right now I'm running in the public cloud NiFi 120, which is the latest release version. 209 has just started, and we'll talk about that on May 3rd. Well, the committers will. I don't have to do that, which is great. But that version will, if you go into public cloud, I could downgrade too. So if for some reason you're running a flow and going, hey, something's not right, let me downgrade a version. Or when it's ready, you choose when you upgrade it. Because it's all running in Kubernetes pods in the public cloud, I can run, every flow runs in its own environment with its own version, its own JVM, all protected in pods. And you start with, minimum node size, and you could scale out to as many as you need to. But yeah, so I can run a flow that has version 116, a 120, when 121 comes out, that one. When 2.0 comes out and has the cool Python processors, we could do that. Lots of different stuff. Doesn't seem to be a lot of people super excited about Kafka, so I'll stream through that pretty quickly, and we can maybe bring that up in the other discussion. The only thing I wanted to show is I'm at the Kafka Museum in the Czech Republic in front of the giant cave for Kafka with a Kafka shirt on, and I thought that was pretty cool. I don't know if other people thought that was cool. They didn't understand what the shirt meant at the museum, and I was very disappointed that they had never heard of Apache Kafka. So, but it's a really awesome museum. If you're ever in Prague, it's right next to a really good cookie place, and beer is $1. So go there, even if you don't like beer. Do not get the Czech's version of absinthe. Is very strong. You would be surprised. So Kafka is really cool, but you can use it, and it can be replaced out with Pulsar pretty transparently, or Red Panda. The nice thing with NiFi is, I can work independently of that. And you saw we could do a lot of stuff there. We could also run the smaller version of NiFi, because sometimes you don't have something big like my laptop to run your server. You might want to run it on a Raspberry Pi or on an ATM. In somewhere in Southeast Asia, we have NiFi running in gas pumps. And that's how they change the prices and check for monitoring and censoring. Pretty cool. It's also in some of those kiosks when you check into the airport. It's a pretty cool little agent. And again, that's probably streaming, because there's a lot of these devices pushing data out. Sometimes they push them MQTT, sometimes Kafka, sometimes raw TCP/IP streams, sometimes SSL. Again, is SSL streaming? I guess. We go through that. This is also my cat, for the people wondering about the cats. Are we streaming yet? People were asking about Flink. Flink is kind of the new coolness. For me, the part that really makes it better is not having to write, Scala, Java, or Python code for everything. I mean, you certainly can, and there's some people good at it, but being able to use SQL and have it run for everything. What scenario? There's a C in scenario. I got you. Let me finish 2 more slides, then we'll look at that one. More questions. We charge by the question. Thank you. So we have an engine that runs Flink SQL. A lot of people do, and they're all really awesome because the underlying technology is really awesome. The one thing I've been surprised to see is a lot of people use PostgreSQL as a cache somewhere in here for doing some materialization. That seems really common. Postgres has been around a long time, so pretty cool. What's nice with Flink is pretty strong SQL. It supports most of SQL 92 with a couple extra grammar add-ons to do some things that don't make sense outside of a streaming context, like looking at windows of data over time, which you could do some pretty cool stuff. And for me, I keep it usually simple, just doing things like max min, doing joins, maybe unions. And then the best part is being able to do an insert into. So how do I write my code? Just write select from a Kafka topic, join it with a join from a Pulsar topic, insert it into a Kudu table or into an Iceberg table, or insert it into another Kafka topic. If something's in Kafka or Pulsar, someone can consume that really easy. And maybe that's another NiFi app. Maybe it's multiple people because you can have your own ID. So one app consumes it, pushes it to a database. One looks at it, pushes it to logs, does some analytics, whatever you have, or connects it to another engine. I mean, tomorrow I'll talk about once we get it into Kafka or Pulsar, I stream it to Pinot, then I could do my cool analytics apps on there, maybe Apache Superset, show some cool stuff. And again, when do you do the SQL in something like Flink or in Time Plus or Decodable or Rising Wave? And when do you do it in Pinot or in Kudu or on top of Iceberg? There's a lot of debate when to do that. For me, when I'm doing it in SQL, something like SQL Stream Builder with Flink SQL, I am still making my app. Maybe it looks like analytics because it's SQL, but really this is code. Like I want it to have some action. Maybe I'm looking for fraud alerts on a credit card, which I could tell you is a use case that's used. Maybe I'm looking for other kinds of alerts. Maybe I'm checking. I've got 1 million devices out there sitting on trains, checking the heat of the wheels so we don't get another 2 major railroads blowing up. Looking at that real time and making decisions then. So before it gets stored in a database somewhere, which might take a couple of seconds, even a fast one still has to go somewhere. Some of the nice things with these things is I could push them pretty close to the running thing. And if it's that critical, I could push it to the Minify agent so that query can run, because NiFi has a small SQL processor with Apache Calcite that'll run on that device. So if I need to know some stuff before that second of network out, or if I'm on something that the network is turned off temporarily, I want to be able to do it there. So if it happens before someone, has time to store it somewhere, that's when I try to do it here. Otherwise, you can wait till it gets further up the stack, maybe do it with Airflow and Spark. It's really, but this is costing you, it takes more resources. There's some trade-offs if you're going to push it to the faster stream for most stuff, especially if it's a decent amount of data. There's definitely a debate there. Looks at schemas. Everyone likes schemas. What else we got here? You can write some crazy SQL. And what's cool here is they're joining together data from Kafka, Hive. Yeah, people still use Hive, Kudu, and doing some crazy stuff over some windows and stuff. It's a little too complex for me, but it works. And then they store it in a table. Again, when you store it at the end, one of the reasons might be some things take too long to run real time unless you're throwing a lot of resources. There's certainly people with 1, 2, 10,000 node clusters out there. Most of us don't have that budget. My budget is my laptop, so I can't do that. So for some people, instead of doing that, I will do a little bit of analytics real time, and then everything though gets stored somewhere so I could do those bigger analytics, so I could train machine learning models and deep learning models and get at that data. You need a large language model to train something like ChatGPT. You're gonna need a large data model to train other data, and there's a lot of different data. One thing we forget with streaming though is, having some kind of data governance. Data governance is pretty well known for the people in the batch world, or, slow data. You don't update for a minute, that's slow data. But you need that for streaming as well to know, who's touching the data, when, are they allowed to? Again, that lineage, we have that really strong in NiFi with adding Apache Atlas. Like I mentioned, all the Apache projects. I forgot Apache Ranger. We tried to see if we could list every Apache project I'm using, and I can't, and I'm using them. Sometimes they just kind of work, so you don't have to worry. Like Apache Knox, the guy who writes that really cool guy, you don't have to know that it works. It just does it for you, which is very cool. They added some GitHub, which is cool way to do projects with Flink SQL. You got the software development lifecycle. I'll go through some of this in code as opposed to showing you 10,000 slides. And yeah, I do have a live car one that I do. I don't do that here because I couldn't drive from Jersey here. That would have been a good demo though. I was going to do my live airplane tracking, but someone's blocking it right now, so I have to wait. I don't know who's blocking that. We'll have to talk to them, but we'll do that later. Let's get past that. So NiFi, been around for a while. We talked about a bunch of it already. I will show you some more about this. Built-in back pressure is a really cool one. A lot of processors are built. The processors are those little boxes that do something for you, so you don't have to rewrite the wheel every time you're doing something. Again, get some data, do something to it, send it somewhere. It sounds pretty easy, but the thing I forgot to mention is, sure, I can do data that looks like records, JSON, comma files, whatever you have, Parquet files, stuff that looks like a table and things that are a table, but sometimes things don't look like a table, and you don't want to do that with Flink or Spark. If I have an image, do I want to send that to Spark? Maybe to a Spark machine learning model, but I'm not going to ingest images inside of Spark or Flink, but I can with NiFi. NiFi can take any binary file, including ones that are encrypted with pretty intense government level encryption. Or it could take an image, or I could pull stuff off live cameras around a city and do 1,000 of them at once and send those over interface into a machine learning model, get the results of that, and in real time look at the results, track a person on the camera, send that to there, and be Batman. Though I have not done the Batman thing in a long while. But we can get lots of data like that. I'll show you an example where I grab a zip file of XMLs and convert it into a stream of weather data. Pretty cool stuff. We mentioned the provenance. People who like to write code, you're eventually going to write code. You can write code. Right now, you have to write it in a JVM language, and then it gets deployed as a zip file on the server, gets loaded, you get extra processing. In the next one, you'll be able to do that in Python, so you can pull in all that data you wanted. Load balancing, you could actually control how you load balance between every single step of your code, which is really cool. You have a queue between each step. It's not a Kafka or Pulsar style broker, but it's a queue that makes sure you don't lose your data, keeps it in order, but lets you do things like prioritize it, distribute among different nodes in your NiFi cluster, and do some cute stuff like that. We support working with records, like we mentioned, but some of them are pretty exotic, like doing IP fixed data, doing some other formats of data like syslog, doing log files, Windows events. Again, we do a lot of stuff with logs. Having that calcite engine in there so I could run SQL on anything that looks like a table. If it's an image, probably shouldn't run SQL on it. Probably going to give you an error. Python, we're going to let you write your own Python processors. I'm going to go into that cloud product. If that NiFi looked too hard, we took the most common use cases and made them ready flows. So all you have to do is click it, put in a couple parameters, pick the size, and press deploy. Pretty nice way to do that. Once it's deployed, it's in a catalog. Get access to that all the time. Deploy it, set a couple parameters, say how much you want to size it, how do you want it to scale out, and then define everything you want to run as a metric. So you can see all the performance characteristics, but only the ones you want, and at a very granular level. You could say, I want to see the whole flow. I want to see one part of the flow. I want to see one connection between one flow. Show me if it's between this value and that value. And if so, give me an alert. Pretty cool way to be able to deploy stuff, and gives you the ability to monitor it. And we'll show you that dashboard. And then you could deploy it. I could run it with an environment in the cloud, so I don't have to have NiFi running. It gives me a custom designer, lets me build it there. No other things on the server. You have your own clean Kubernetes runtime to run it. You run it, and when you're done, you could deploy it to production. Here's where we could do those NiFi upgrades, which is nice. So when those fixes come out, having Joe Witt and the team sitting there developing new ones, they could quickly push this out to the cloud as soon as it's safe to do so. And you could decide to pick that. Or when you deploy it the next time, it'll just pick the next highest version to put it out there. And right now it's 120. I've got a couple best practices to get away from some of your tech debt. My tech debt is I have 3 12-foot skeletons in my house for Halloween, and trying to store 3 12-foot skeletons, and I put them in my office. So it looks a little creepy. Those are skulls that are like this big. That is my tech debt in my office. Make sure your version control for any streaming, version control everything. Manage things in the public cloud, makes it a little easier. Always use DevOps and APIs so you can repeat things, because it's great when you got something working, but if you don't remember what you did, it's really hard when you got to deploy it again, and that happens all the time. Make sure you use the right part. I know someone brought that question up. When do we do NiFi, Kafka, Flink? When do we use another tool? And, if I swap out Kafka for Pulsar, or Kafka for something else, or Flink for Time Plus, or Flink for Quicks, is it the end of the world? No. Because once I have something in Kafka, I could decide, well, let me run one job in Time Plus, one in Flink, one in somewhere else, because they may have some of their own enrichments, own features, or things you want to try. That's the great thing, not being stuck in one part of technology. If something might make sense for one use case, or maybe one customer partner says, I do everything in this environment, push the data to that environment. Same thing, if I'm doing some stuff in Snowflake, I could pull it out of Snowflake, work with it in a stream, push it to somebody else, and we're in a good place. If NiFi looked at all interesting, there'll be the 3 main people on it. I think I might speak for 1 minute at the end too, trying to get people to come into the environment. I'm going to be doing a daily webinar during that session there, and we're going to go through building your own apps and hopefully get them published as a ready flow, where you get a nice $2,000 prize, and also get the fame of being the person among all these NiFi people who wrote something cool. Download my cat. We already had people do it, so it's doable. Tomorrow, speaking a couple blocks that way, or is it that way? I guess at home, it doesn't matter to you, it's somewhere. And then May 10th, I've got to talk at the Open Source Summit. May 9th, I'm speaking at the Garden State Java Users Group. So that's the slides. We will give them to you. We'll go through, if everything didn't time out, and it go through my environment. Maybe I'll do questions before we do a demo. Is there any more questions in there?
Questions. Okay. Are there some patterns we can follow for developing a streaming architecture? Some prescriptive guidance on going about it?
There are a couple of books, and there are some examples out there. But other than the real basics of start simple, like to me, start with NiFi. And the reason why is low barrier to entry. And it'll do most things. You might go, well, I did it, but maybe it really needs to be a stream. Maybe it needs to be in a faster tool like Flink, or maybe it's really batchy. Maybe I need to write code. Maybe I need to write Python. Maybe there's a need for some Java or Scala or Rust or Go or Carbon or some language. Do the easiest thing that works. Get it working. To me, this is why I like NiFi. If I wanted to start programming, the first thing I would do is if it's a REST endpoint or a file, get the link to the file. Get the link to the whatever it is. And for NiFi, I set the parameters. I run it once. I've got that. Now I can figure out what's the next step I need to do. So I could examine the data and go, what is this data? It's a zip file. Okay, what do I do with a zip file? First step, unzip it. Okay, it's not zipped anymore, but now it's still, an archive of a bunch of files. Okay, now I split it up into all the files that are in the zip. I've got those individual files. What do they look like? You got to do it very iteratively. That's why I like NiFi. It lets you do that live. I don't have to redeploy. I don't have to rebuild something. No expensive costs. I can run it in Docker, Kubernetes, or this is just running on my laptop. So I got all these files separate. What do they look like? Everyone's favorite XML. Do you want to write some XML code in Java or in Flink or Spark? I don't want to write that. Okay, get me the current date in there and convert it into something. And then I'll put that as Avro and push it to a Kafka topic. That's some actual code you have to write. I don't want to write that code because there's no business value for me writing that. It's busy work. Why write that? So what I'm going to do instead is I'm going to get rid of something I learned by looking at these airport ones is I just want weather reports at the airport, because otherwise they're sitting in the middle of the desert, or if they're at a secret military base, I don't really need that weather report. That's not very valuable. So I just filter those out. Again, no code. Ooh, I forgot to pause there. Now it's just going to stream by. That's the problem with streaming data. I get that 5,000 files at once. And that's very cool when you're running stuff, but doesn't look cool in the demo because all the 5,000 records happen at once. I don't get to really see them. But this is the code I did to take XML, convert it to JSON. What's nice with NiFi is these readers here, I don't have to hard code them to be XML or hard code them to anything. I'm just saying, guess what that data looks like. If I knew if it's the same data every time, I could pre-write a schema, put it in a schema registry. It'll use it to parse the data. If I don't, let NiFi figure it out for me. It has a couple different ways to infer that. Pretty good way to do that. We also have the ability to not have to have it hard-coded to it happens to be XML. I've got a parameterized reader for this, and it could just look at it and, pass in those parameters to say what it's going to be. So this converted it into JSON, and I'm sending that here. Did I stop it somewhere? No. Here, I just wanted to add some metadata. So the nice thing with NiFi is everything comes in as a file, and it comes in as an event or message together. And without changing that data, and again, I have audit around there, so I know if it changed. and everyone will know what to change. I put metadata associated with it and have it go through the pipe. Here, I just want to be really certain that it's JSON. So everybody knows. I give it a schema name, so I want to use schemas. I could do it. Because the data is moving so fast in NiFi, it makes it very hard to demo. So instead of popping 5,000, nice thing with NiFi is it can work in any size group you want. So if I want to send one event through at a time, great. If I want to send 5, 10, a million rows at a time, couple gigabyte files. If you got enough RAM, I could send, I have seen someone push a terabyte file through. That's not the best thing because you need a lot of RAM for that. But I guess now that I have 64 gigs of RAM on my phone, maybe it's not as big a deal for servers anymore. So I just split those up into individual records because it's easier for me to work with them. And it looks better. I can see all those files coming through. And then here, I'm just going to add some extra value to that. I decided the data that the weather service gives me isn't quite complete for streaming. I would like a timestamp, and I would like a unique ID on that. So I add them to that data. So now I have mutated that data and added extra fields, and that shows up in the audit log. So you'd see that. And that data I can push to Kafka to tell someone, hey, someone changed this data. So if I have a data contract that says you can't alter this data, I know. So I could have pushed that raw stream somewhere else. And I tend to do that with Kafka. As soon as I get the data and it has no errors, push that raw safe data into a Kafka topic and set in case someone wants to go back to the earliest and process it all later. You could do that. And then here again, I stopped it. It's waiting. I'm going to push it to Kafka, connect to my brokers, put it in a topic. Here, I'm just outputting it as JSON with a schema. I could have put it in Avro or Parquet, or most people in streaming like JSON or Avro for their data. Could be Protobuf, but JSON and Avro tend to be the most preferred. Add a key to it, add some properties. That's it. Push it to my record. And I just sent 9,000. That's why I try to put it up as an individual file so you can see it going. Because then if I want to read it somewhere, they just all came through. So it goes a little too fast to watch. So it's not the best. I refresh, it's gone. Pretty fast. Do we have any more questions? Otherwise, I'll show you the...
There's always questions. So there was one statement based on what you were just talking about, just that NiFi is a great tool for thinking, learning about data flows by investigating the various configurable parameters for different processors. Why are the parameters here? Helps you learn. So it's just a statement. That's good.
Oh, that's probably one of our people. Thank you, Mr. NiFi person.
Do you see much use for Avro? You're mentioning Avro for managing schema. How about versioning of schema definitions?
Yes, people use it. Is it better than JSON? Yes. Now, not every tool supports Avro. Okay, our buddies do. So use Avro because you could use it with Flink, Time Plus, and some vendors, but some people don't want to support it. What's nice about Avro, I know it's not the newest, flashiest one, but it has the schema there. It's binary, so it's a little bit lighter weight, a little faster to read than JSON. Could you push it into Parquet files around? Not every tool wants to read them, and a small Parquet file is not great. Again, the problem is a lot of people want individual events or records in the topic as the message. If that's the case, Parquet's too much overhead. Avro's only a slight bit of overhead. If we look at, do I have some binary data in Avro I could show you, maybe? No, is this one JSON? No, it's not Avro. I get Avro somewhere. Problem with too much data, maybe air quality. It says Avro. So that schema. Let's see. Is this Avro? Yes, this is Avro. So it automatically with here, because I have a schema, this viewer SQL Stream, SQL Message Manager will convert Avro into JSON for viewing. But if I decide I want to just show this as bytes, you can see it's just bytes. I think if you showed a string, it'll show you a weird string with some binary in it, because that's the raw Avro. It's got a little header and it's got a bit of the schema embedded, but it's binary. It's a little smaller than JSON, so it makes that a little easier for you. So Avro is still used. Maybe people will switch to another format. Right now, it's pretty universal, pretty good. Most people don't compress it, but you can. Again, with the amount of pipes people have, the size of these network systems and the size of the memory, people tend not to have big messages anyway. I mean, they're a K or less, couple of bytes. Why compress them? But maybe.
So we got 3 more questions. Is there guidance for running NiFi on public cloud like AWS or for use with Kubernetes on-prem?
Now, the Kubernetes on-prem is, there's not, I know there's a public Kubernetes operator out there. I don't know how well that's supported. For the Cloudera stuff, it's managed for you in this environment, makes it really easy. One thing we didn't mention is there's yet another variation of NiFi as it tries to be everything to everybody, because it's been around for a while. There is another way to distribute NiFi, and it's kind of interesting. So not only can I deploy it to one of those Kubernetes environments, I could deploy it as a function, as a serverless function on one of these things. So you design your flow, and then with a couple parameters, push it out to Lambda, Azure, or Google Cloud, and it gets triggered by those things there, and it runs as a very small serverless component, doesn't have any of the other trappings around it. They work really nice, run pretty fast. It is a very interesting way to do it. Now, obviously, something that runs stateless from an event to an end can't be like a regular NiFi flow that runs continuously waiting for data. It is something that has to be triggered, like take a Kafka message, do something, and then be done. So it's got to run like a transaction or a job, which is kind of cool if that's what your use case is. Of some people are like, I want to read something from Kafka, do some magic stuff, and then if everything's good, be done. Maybe push it to another Kafka topic, store it in Iceberg, just be done. And then that full message is processed. What's good is when you do that, it's done. If it didn't complete, it'll get pushed to someone else and they can run it. For certain use cases where you never want to lose data, and if you have to run it again, that's fine. That is a very interesting way to do that, and pretty cool. Now, we talked about those ready flows. Those are that NiFi accelerator, NiFi in a box. I pick one of them here, maybe the one for Iceberg, and it tells me what it'll do, how to do it, what sources it'll take, and I can create a new draft from that. Pick my Kubernetes environment. Ooh, which one? Well, I'm getting in trouble putting it in the wrong place. I'll blame the Meetup people. So I create it. It starts it up for me already. It's not running yet, but it's given me an environment. It's set up all the processors I need, gives me the environment, set up the parameters. All I have to do is if I want to change this at all, I could tweak it, add some extra stuff. Otherwise, set in my security parameters, set in, what Kafka I'm talking to, start it up, and then I'm ready to go. Right here, I'd start a test session. That lets me code, test it locally, make sure it's working in this isolated environment. And when it's done, then I just do a deploy, and then it will be running out here, and I can monitor it. Like this one, I could see the different KPIs I've set for it. Pretty straightforward there. Any other questions?
What scenario would we need to stream Kafka NiFi Kafka?
The way I've seen that is, was it Kafka NiFi Kafka or NiFi Kafka?
Kafka NiFi Kafka.
Kafka, NiFi, Kafka. So you have someone put data into Kafka. This is a common one for like CDC. So I have Debezium sitting somewhere. Someone did a table. It got a change. That change triggered a message into Kafka. NiFi gets it. Maybe he's doing validation. Maybe he's checking a cache. Maybe he's enriching it because the data that came from that original table, ugly, weird formatting, weird fields. Maybe I'm going to change, weird binary letter codes into something that makes sense for my new environment, put it in that new format, put it in a new schema, then push it to another Kafka topic that may be a CDC going into a different table, maybe going to Snowflake and, going from Oracle to Snowflake. That's a common one. So, and then maybe on the other end of that Kafka, I could have NiFi push right to something else, like right to Snowflake, but I may want to have someone else do some further processing. They may be in another environment or in another country where they may not want any enrichment or changes to happen outside of their country or outside of their cloud environment. So we push that raw data perhaps into that environment and have NiFi do it there. Or it's NiFi that's running in a small cluster in an offshore oil drilling environment, which I've seen. I didn't have to go there, thank God. And it runs it there and then builds up stuff in its queue and then pushes it out when they get a network. The network pops in and out every couple hours, send it over and it gets processed somewhere else. You kind of have that pipeline moving around, maybe starting off in a moving brown truck, goes into a local data center that's also where they're handling packages. That goes up to a cloud availability zone, goes through some things, goes somewhere else. With NiFi, Kafka, NiFi communicating at different levels of security, enrichment. But the nice part is I could have one data governance over that, one lineage. So I could track all that lineage with something like Apache Atlas, which is kind of cool.
Last question until people add more. Do you believe Apache Atlas is still relevant with regard to data, Avro, or otherwise versioning?
Yes. Yeah, I mean, there's some other ones now too. And some of them are based on the project that is the basis for Atlas. There's IBM and some open group working on it. I don't know where that is. Being the streaming guy, I should know more about the lineage, but there's too many projects. Someone else do that one. If there's no more, I want to get a mic for my friend if you're still ready. Do a couple of streaming questions if we want this open discussion. If not, that's okay, man. I'm putting you on the spot, but they can't see you, so they don't know. Oh, maybe we could do it together, unless it's specific to NiFi.
Is there a role for the Apache streaming world?
Is there a what?
Is there a role for
and we could probably drop off background. Is there a role? As the streaming guy, I don't talk about Hadoop because don't really have to use it. To me, the projects themselves now live on their own because they're put together with Kubernetes. I guess I should share something. Want me to share something? Maybe I can put the slides back up. I don't remember when I accidentally closed them, but we'll put them back up. At least put up some contact information. We'll put up all the slides and the links to things later. But to me, the more important part than HDFS is something like Iceberg now. And if HDFS is a good thought of as like just an SDK or just parameter, like we were talking S3, S3 compatible layer to put data to. And at this point, I think it probably should be Iceberg. I mean, there's two other ones and they're pretty good too, but Iceberg seems to be nice because there's some really nice features that are enhancement on top of S3 or on top of ADLS2 or on top of HDFS. But yeah, if you're still interested in HDFS, look at Ozone. that is a very interesting project that scales very massively, works with Iceberg and does some cool stuff. I don't have to worry about that. I know it's cool though. So, but if there's no more, if there's a question, is that interesting to you? Do you want to bring that up for the HDFS?
Is that okay to drink?
Yeah. Oh, I gotta get him. Oh yeah.
I have one. Hi, this is Joe. Thanks for the inviting. And Tim mentioned CanPass a few times in the talk. I guess you might
$2 each time.
And you guys probably don't have idea what is CanPass. So in short, it is a new player in the streaming area, and we really turn Kafka as a very easy to use SQL database.
Yeah, I think I wrote an article and an example program using Time Plus and Pulsar. I think it took me 20 minutes. And I'd never seen your product before.
Yeah, I guess we share a lot of similar passion, right? I mean, for example, one of the good strengths of NiFi is really the ecosystem and also the easy to use. People don't have to follow like 20-page tutorial to understand what's going on. You just click, and do this intuitively. And Time Plus, we share the same passion. So today, people mainly using Flink or Spark, but it's certainly very powerful, mature, but you still have to learn everything in the first few weeks and set up a fairly big cluster. And in Time Plus, we try to make this much easier. You have a very nice UI using SQL as a primary interface to query everything. And also you can send to different place, including Slack, right? Which is not really a focus of Flink.
Yeah, Slack is a strange one. Like somebody like, can you push it to Discord? I'm like, what use cases grab a bunch of streaming data off of some system? But then again, how do you do alerts? Maybe that's where your people are for the alerts.
Yeah, for example, we somehow either say eat our own dog food or drink our own champagne. So in Time Plus, we use Time Plus a lot for sure. So for example, we leverage stuff like Auth0 for our single sign-on and for new user sign-up. So every time when there's a new user sign-up on Auth0, Auth0 actually have this webhook. You can configure a link. Tim, you mentioned this idea about whether REST is a streaming. For me, why not? I mean, you can get event by event. And you get a very low latency, right? And if you can really have a nice way to support different webhook, you don't even need to write any code. So in our case, we just configure our endpoint on the Auth0. Whenever someone sign up, then I can get this event pushed to Time Plus. And we have a SQL to understand, like, say, hey, kind of roughly which country it's coming from, and it can send me a Slack. And it also power up our like dashboard. So to me, it's a very nice way to engage with the users, right? So yeah, I mean, data processing is such a big topic, and the streaming sounds very fancy, advanced, but actually can do many interesting things with streaming, and it's not so difficult.
Yeah, it's pretty cool. The one thing that I've liked is, sometimes you use one tool, sometimes you use another, but usually you use them together. Like, can I write everything in NiFi? Should I? Like some people like, if I use NiFi, can you get rid of Kafka? Sorry, there's places for things. People brought that up a couple times. Like neither of us wants to use NiFi or Time Plus or Flink as your queue or as your store of data for that, recent data that you want immediately.
Yeah, I mean,
different places.
It's very difficult, even impossible, to have one thing fit for all. And we all in this big data ecosystem, we play our role to make something easier or cheaper or faster. For example, Time Plus, we do have the vision that is, we're not just processing what is happening right now. We also have our own storage. So for example, like you might configure the TTL, the retention policy in Kafka like 7 days. But if you want to query data older, you either have to set a very long retention policy, which maybe make the Kafka more kind of costly.
Yeah.
But you can also say in Time Plus case, we keep getting data from Kafka and store in our own engine. And you can run a query, say, what's the current revenue vs what's the revenue like 3 months ago. And we do such kind of area, but we are not really replace like any kind of OLAP or Snowflake, because we want to make you have more context data about your streaming. That's all. But now we are not really building the other data warehousing.
Yeah, I think the stateful thing comes up. I want to get to those. I saw a couple of questions come by. Is it all from Harry? Who's this Harry guy? Harry has a lot of questions, which is good. We don't want people to like, okay, streaming. So you want to feed some of this, and we'll.
So before Harry, there was one. It was more of a one before that. It said, "Thanks. You mentioned 2 good books or resources on streaming. Would you please mention what those are, or you can give them to me and I can post them, or maybe there's more books." Or you just threw out a number?
There's probably more than 2. I'm trying to think of the names, but I'll look it up. There's a free one by David Karamgard from Stream Native on Pulsar, but it covers a lot of streaming. And it's, again, a free PDF book. I'll make sure you get that link. There's a couple other ones I've seen that combine different levels of streaming. Unfortunately, the streaming space changes pretty frequently. So by the time it's in a full book, I mean, the paradigms are still there, but.
Yeah, I know someone also working on the book, Streaming Data Mesh.
Oh, yeah.
Even streaming database.
Yeah, I mean, I think a lot of it is follow the articles, follow the demos. To me, the written part is good, but to see it, so you could try it and go, okay, I want to try it, because it looks good on paper, but then you're like, oh, I have to do it. Sometimes you see some of the architecture, it's like, well, we've got 50 layers here. Like I was talking to a telecom company, they're like, we've got this layer and this layer and this layer and this layer. And they're like, oh, they're like, we will never lose data and all this. I'm like, that's great, but there's a lot of planning you have to do for that level of stuff. And sometimes maybe if you started clean, maybe you don't need all the layers.
So Harry says he's a long-time enterprise architect, so he's seen a lot and always has lots of questions. So that's where the questions come from. He said,
good, man, a bunch of us have been around probably for too long.
So in his list of questions, we'll start with the first set. How about Kylin? Did I pronounce that right? For cube storage, for multidimensional analytics. There's also Alluxio for managing file systems across platforms. Not sure if that comes into play here.
Well, I haven't seen Kylin in a while, but there's a lot of projects. Alluxio is kind of cool. I knew some of the guys from there. It's nice for having that in-memory layer that acts as a file system. I've seen people use it to plug it in because I believe it's S3 compatible and some other ones. So having like an in-memory giant cache is nice. You probably have some of that already. Flink has that as part of their state store.
Yeah, that's one of the big, more like favor/debate is whether you want prefer using like SQL or using Python or Java or other DSL to processing the data and
API.
Or the API, yes. So in our case, we think even SQL is not the perfect language, but it's a common language. I mean, to some degree, it's even like a common language for the streaming database, right? I mean, you can describe your requirement fairly clearly using SQL. So of course, there's a lot of kind of a prototype to see whether we can use in natural language to query database or even do streaming. Maybe, but you have to be very precise. Then maybe SQL will be very close to that language.
Yeah, SQL's a pretty good description for it. It is a little old. I was talking to Peter from Startree, and he's like, you got to come up with a new grammar to kind of describe these things as they keep moving forward.
Yeah, we are lucky enough in that group. So we are under Streaming SQL working group. It's part of the ISO and other standard that is, we work with a few good player in this domain to see what kind of extra keyword semantics we need to add to SQL to make this more modern and can express enough to about, hey, I want to understand what's going on for the past 5 seconds and I want to get result every 1 second, stuff like that. And how you define whether the data is late enough, how you define what's the frequency. So there's some addition to the SQL for sure, yeah. But it will take time to stand up, yeah.
I am very curious if in a year, a large language model will become an Apache project that is a standard interface so I can write natural language queries that actual work. I mean, we've been trying them since the reason why you keep falling back to SQL. People have been trying them back. I don't want to say how old I am. Power Builder days and early SQL days, and they weren't quite right. So that's why SQL, everyone can agree to it. It's probably not the best paradigm for real time, but what else is there? Maybe once we can agree and get natural language working, that'll be nice. Yeah, you could go back. I mean, I remember doing some of the stuff on the speaking into the computer very long time ago on fancy audio cards. But yeah, we can go back to pre-computers for people attempting this stuff.
Yeah, and even I guess almost every week I saw some new project. For example, there's one called Prequel. It's kind of a new language, inspired by SQL, but more expressive. For example, you start from, not select, stuff like that. But the problem with that is people are so used to SQL, right? It's not really about which one is the best. It's more about which one is the common language.
That's kind of brings up a thing that I put something out on Citizen Streaming Developer, because at some point there's the most experienced engineer wants to write very, very complex code that solves hard problems. And then in the middle, there's a lot of people know SQL, maybe a little REST. They can do a lot of basic applications now, especially with the power of different tools to spin up on demand. They're in Kubernetes, strong SQL. And then hopefully in the end, there'll be more that someone could just describe the problem and do it. But, there's still a lot of gray area in between that. Like, that's where I kind of try to get people to NiFi to kind of gel what they want to do with the thing, get it to a place where they can maybe hand it off to someone who's really good at SQL. Like, we need those people who are doing 20 years of Oracle and SQL, move over to doing streaming tools and come up with the extra functions, the extra paradigms, and maybe some codify. This is the best way to do this type of windowing query or some other query. And then some of that could be auto-generated by someone doing some natural language like, hey, I would like to get the weather over this period of time where it takes into factor this other data stream and blah, blah, blah.
I guess we have a question in the room.
Oh, in the room.
Yes. It should be have a higher weight than the online questions.
This is not virtual. We're really
We are real. This is not
I don't know. Some people said that I am a bot.
Who knows? I think I already forgot the original question, but I think by now, one of the things I was considering is that there's this whole world within SQL, which is one world, but then real-time and streaming is not necessarily always SQL. So just on this slide specifically, it says like there's a world sub 1 millisecond. The place where I live, it's mostly between 10 to 100 nanoseconds, like the kinds of optimizations that we're doing. So even just parsing SQL statement would take significantly longer than that. So there's been a precedent within the history when people decided to standardize the binary interface versus, let's say, a text-based interface. And it's been following me like for many years, like why people haven't standardized an SQL-like standard for that would be binary for those kinds of workloads, and would agree on that, especially like as we get to much higher throughput systems, potentially lower latencies, but not as much because the CPU frequency isn't growing that much. Is there any movement? Do you know any projects like this?
Yeah. So I share my kind of what I observe and experience, not have to be the perfect answer. So you mentioned that is even parsing the SQL itself may take some time. That's exactly right. That's exactly why there's a thing called streaming SQL. So in our case, for example, we have some clients in this real time or between the real time and real time. That is, they are expecting single-digit millisecond. They make it very clear when they talk to us. Hey, I can do this with a sub-second already. Can you do like 100 millisecond or even 10 millisecond? If so, we can do the POC. They are on the fintech area. They want to understand like, hey, all the trading kind of signals, whether someone is doing something very specious, whether the marketing value is getting too high or too low, whether they want to add more or like trade stuff. So they have very high expectation for the low latency. In our case, we're leveraging this concept of streaming SQL. So you run the query, and the query always run. Or you only passed once, and whenever there's a new event or there's a certain interval, the new result will be pushed to you, no matter using like SSE or WebSocket or using other protocols. So by doing so, it's we leveraging the underlying hardware as crazy as possible to processing the new event. And as a consumer, you always get the latest data, and it can be single-digit millisecond. Yeah.
Yeah, that initial parse is the only part. Once you're running the continuous SQL, continuous.
And what is better that is, for example, you want to get stuff like, hey, what's my total amount of transaction in this hour? You want to get this real-time data, right? In regular OLAP system, you need to run this query every second. Then every second, actually, you scan the data again. So, for example, in the number 3 seconds, you have to rescan everything in the past 2 seconds, which is a waste. And in our case, or in this streaming database where we do this incremental update, we know what is the data in the 2 seconds ago, and we know what's the delta, and we can add to it without rescanning everything in the past.
Yeah, that's the stateful streaming.
Yeah, stateful, and also like differential, the data flow, all those things.
That part is kind of clear because like almost all even like low-level systems, whenever they face continuous events of similar nature, like they can just prepare for it once and then repeat the action. So most of the similar projects that would be implemented in lower level languages would just compile the statement and then would just simply map the contents until like this executable area would run on top of it and would give you the result. This kind of originates from a point that in the last few years, we've seen the decoupling of storage and compute. And this means that like the kinds of abstractions that we use may have to change parallel to this. So if we decouple one from another, the storage part of the server, now decoupled from compute, will be replying to a much more diverse set of queries than ever before, because now it has many potential clients, every one of which receives a very weird queries that are always different from subsequent users. And it will generate a lot of like those unusual events on the server side. So I was curious like how much we can actually port into some binary standard, maybe not the full SQL, but the fine-grained, very small operations. Actually, like myself and my company, we've worked a little bit on that side to the extent that we need, not to the extent to which others may benefit from it potentially. And I've seen that actually like within NiFi, so like the C++ implementation, there is a project that a lot of companies use RocksDB as a key value store. So let's say if you're using something like key value store abstraction, I think it's kind of super common across the world. And I was a bit surprised that we haven't standardized that part earlier, because like you do operation like set and get, and sometimes you do a range scan. The keys and the values are almost uniformly binary strings. So some time ago, we implemented the C99 standard, and on top of or around it, a bunch of other high-level wrappers for any key value store abstraction, because we saw that kind of everyone needs something like this. Would you see this as like one of the potential steps in which we can go? And I guess you may remember projects within like Apache Foundation that are somewhat related. I think there's Voltron data that works on Apache Arrow, and then there is also Substrate. And I'm not sure if Substrate is part of Apache or not, but it's essentially also an attempt to kind of design a binary standard for all kinds of execution tasks that people would want to run on top of the storage.
Quick comment that is, maybe Tim can add more. That is, again, RocksDB is great. I mean, Flink using it, we're using it by ourselves too. And this is great kind of binary to the key value store, as you mentioned. Even I think, I'm not sure why you know the company called Rockset.
Yeah, of course.
It's a it's a SaaS-based database, and they actually the core engine team about they can turn this key value store as a real kind of OLAP system. This certain doable, and also I'm very kind of positive to this Avro thing. Even there's besides the GDBC, they are talking about ADBC or Avro-based.
It was kind of interesting, yeah.
Yeah, and because we are all talking about those big data, the column storage, then why we still leveraging this very old school role-based GDBC protocol like forever? It's time to change.
Yeah, I think it's getting close. I think we'll probably see a new project that uses some of these new advancements, and we'll see what language it's in. I think I'm curious where WASM sits in too. It's another new kind of weird. I don't know where they're going with it, but it could be good. It could just be another.
Can be a new Docker.
Yeah, and Docker is kind of. It kind of was a good idea and kind of has some problems.
Arity Lee was saying, seems like Rock.
Yeah.
I don't know about hot. Well, I mean, most people use it embedded. I mean, I don't know. I don't know. Hive's kind of like, I don't know.
Yeah, and for example, you can have a single node using RocksDB, right? But that's not many point you using single node of etcd. What's the point, right? So it's very good to the clustering coordination using etcd.
Yeah, I don't know. A lot's going on with Iceberg as well. Yeah, the Hive part is the metadata part. And I mean, Cloudera is doing some things with some different engines coming in and out. And then again, moving a lot of this to Iceberg because of things like time travel, which is kind of cool. But I mean, there's so much new stuff coming out. If we did this talk tomorrow, we could add 3 more projects. I mean, that's great. It's just, if you're trying to do something mature, it's very hard to know what to pick. And I mean, if you're still doing something in Java, the changes that just happening right now in Java are almost like it's a new language. So with the green threads, with the Grail VM stuff, everything post JDK 20 is, the level of performance is now.
By the way, if you don't know me, my name is Jove. The reason I choose Jove as my nickname, this is not name on my passport. 20 years ago is I tried to choose something like Java lover. So end up with
Nice.
But again, I mean, say I'm working on the database side, and there's a lot of talk, no matter from like partner, VC, or customer that is, hey, what's the language? There's a lot of Java-based system. It's very, very mature, and also Rust and C++. They are, or even Go, right? There's a lot of database written in Go.
Carbon. I mean, whatever language that you use, it seems to be able to develop good projects as long as you have people dedicated doing it, have a good enough project. Especially the later years. Oh, Derby. Yeah, I haven't seen Derby in a while. But there's so many. I miss, what was the one from Pivotal? They had Gemfire XD. That was kind of cool.
It's a memory cache, something.
It was part memory, but there was some SQL in it. And it was kind of funky. It's an open source project. I think it's Apache now. There's so much. Serverless SQL. Yeah, Drill was cool. Drill born Calcite, and Calcite's used in that little NiFi controller. Which I wonder, there's actually talk for some parts where we could do RocksDB and part of those pieces in between there. And then maybe opening some of that to put WASM, drop those in. And then maybe the communication between nodes becomes Avro over. Yeah, Calcite does the SQL parsing part that was the drill for drill. And then that went to Phoenix. It went to NiFi. There's like 9 projects using it, and it's written by one guy. Really smart guy.
Stu. Yeah.
Okay. There's like 2 people helping him, but I mean, that one guy. Which is kind of scary if you look at like some of these projects. There's 1 to 3 major people. Is there a real The silly DB is pretty good.
Yeah, they do a lot of hardening on the
And
implementation
HBase is
side.
pretty fast. I mean, what's real time? Which real time? Oh, this real time. This one you could still do in HBase, but this one, maybe Scilla again, C++, but now with the speeding up of networks, RAM, everything else. I mean, some people just push it all into a very fast RAM and then just do it there. I mean, we saw that Alibaba's doing some of that. Again, if you've got the money, the engineers, you push everything into.
Yeah, and for example, we talked to some fintech customers, and if they looking for like 10 millisecond or maybe 5 millisecond, we can still have a talk. But if they want them lower, they don't talk to anyone. They build everything by themselves. Even have a hardware.
RAM, yeah, it's just special hardware. They got special RAM. I saw a cool library. It's a Chronicle from Java, and the amount of stuff they could do with like this local queue is ridiculous. But I'm like, well, how do you scale that or move that somewhere else? Well, it runs here. You just put it on a big machine or two machines next to each other, and then you put a cable that's this wide between them. Or they have like literally radar dishes pointing at each other 2 feet away. Oh yeah, SQLite, another one going away. But nothing goes away forever. There's going to be people using it every piece of this for decades, man. But I think, what time are we hitting? We got 20 minutes. I hate to leave. I know people are wrapping it up, and we might want to go downtown to the arcade.
Yeah,
There's an after party for the people from the real time.
I think I can do maybe very quick 2-minute demo for the.
Yeah, why not, man?
Just give you some other idea that how we can processing data in Kafka.
Dude, why not? While we're here, man, do it live.
Can
we give him share access? Or very cool.
So I'm
real time, man. Oh,
I'm sharing the screen.
Nice. Anyone could do anything. Don't tell people that until we close this down.
Okay, so I do this very quick. I mean, just give you the idea that say, in our case, we share the same passion of NiFi. Everything should be very easy to configure. So for example, we do have this UI for you to get data from like Confluent, Redpanda, Pulsar, all those stuff. For example, if you're choosing Redpanda, you just set those fields. So after that, you get a very nice data lineage, kind of like governance. You do get the idea about, hey, I configure Kafka source and send the data to my data stream. Then you can build some interesting dashboard, for example, like this. So I'm building. So part of Templates, we try to make this easier for you to see the insight from your real-time data, right? So this data is coming from GitHub. It's real data. And this dashboard showing you that is, hey, this data is keep coming, and this is the current hot topic, and this is the event, and this is the stuff. So, and if you run a query, so if you pick any part of the panel, you see the query behind. And as I mentioned, this query is streaming query. It keeps running all the time. You don't have to rerun it. Push the new result to you. And similarly, we can have some stuff such as alert. You can run a query, and for example, I have a demo somewhere to load the latest tweet. And if there are certain keyword in the tweet, they can send me a Slack. So you can do certain stuff like.
I'm gonna have to move that to Mastodon or Blue Sky pretty soon.
Yeah, of course, real-time customer support or like real-time marketing. Yeah, so as I mentioned, everything is very easy to use. So for example, I run a simple query. I get the rough idea about the results. This is in this mode, it's a running mode, and you get the distribution for each columns. And you can also do stuff like count star. As I mentioned, that is, we don't have to rescan everything. Say the first event is like 102, and next one we get this delta and add it to it. And by doing so, you can build some dashboard very easily. For example, I want to create a chart, and you can add it to the dashboard, right? So this is just a very simple demo to show you that is, if you have data in Kafka, in Kinesis, in REST API, there's a new solution for you to make sense of data without learning a lot of new SDK, API, or set up your own cluster. You can just using SQL, the language is familiar, and build a very nice dashboard and alerts. You might send this back to Kafka or send back to, say, Snowflake, if you want to prefer using your traditional BI. But for the data, yeah, of course, and the transformation part or the aggregation part actually can be powered by the new version of SQL. Yeah, thank you for the watching.
Awesome. And he did that live. He did it live. Brave man.
Harry's your new best friend or something.
We gotta have a questions get pushed to Kafka, and then I'll push them to Time Plus and to Flink, and we'll answer them with a prompt GBT thing we write in NiFi. That's the next meetup topic. Is there another?
Yeah, Harry asked, do any of these support pipeline or transform versioning either directly into Git or through export import?
NiFi saves all of its flows into GitHub or your own local Git. We also have our own NiFi repository that's backed by a database. And then when changes happen, we can push them to GitHub. The same with that catalog we were showing. You storing your stuff in Git yet? I mean, I don't see why you couldn't.
Yeah. So everything as I mentioned, that is, that's on your first item of the. I guess it's on your first item of the either best practice or kind of something you have to follow. Yeah, I mean, everything should be version controlled. So for us, it's all about SQL, either create a CQ or like those auto CQ or create a materials view. So you can easily have some version and you can roll back to the previous version. You can leverage stuff like DBT to understand the relationship between them. Yep.
Any of these projects to deploy the same flow to different environments. When I was in the cloud, we just pick your environment. I could deploy to all of them or into a function-based thing. Real easy. That's pretty straightforward. Most of us run these things on multiple clouds. Not a problem. Thanks, Patrick. That's not really a question, but that's. I think it's time to wrap it up. We have another meetup coming up soon, so thank you.